Hello and namaste everyone. It's a pleasure to present our research achievement and finding at this reputed international symposium on current research in hydropower technology. And the research that we are presenting is application of reverse engineering method to model eroded Francis runner. Presenting you, I'm Ashish Sedai. I undertook this research under Biraj Thapa, Bhola Thapa, Aman Kapali, who are from Department of Mechanical Engineering, Kathmandu University, and also a professor from Wuhan University who helped us with the technical part of the research. To guide you through our achievement and finding, let's get started.
Before I move into the main topic, let me guide you through a hydropower development in Nepal. As we all know that Nepal has a high potential of water resources, it is capable of producing up to 46,000 megawatt of feasible hydroelectricity power generation. And if we see the graph on the figure 1, we can see that the hydropower electricity power generation started around 1960-65, and after that it's gradually increasing. And if we see in the graph 2, we can see that the graph between target versus obtained generation of hydroelectricity power generation in Nepal. And from the graph it is very promising to see that Nepal is investing so much in hydropower generation. And if we see the latest data, we can see that Nepal is currently producing more than 1200 megawatt of hydroelectricity every year. So it's a very good development in Nepal in terms of hydropower. So with all the development of hydropower in Nepal, the turbine that is generally preferred in Nepalese hydropower sector is Francis turbine, as it is suitable for a head of 40 to 600 meter. And this turbine is also able to sustain high mechanical stress resulting from high heads. So this Francis turbine was basically developed by James Francis in around 1855, and this is the most widely used turbine in case of Nepalese hydropower system. So moving with the main topic of our research, that is application of reverse engineering method to model eroded Francis runner. And firstly, let me present you a background of a study why we are using reverse engineering method. And the main cause is that the many runners are getting eroded and damaged due to erosion present in the water. And firstly, let me introduce you of sediment erosion. Sediment erosion is occurs due to the sediments present in the river due to glaciers of Himalayas, regular monsoon rain, and general topography. These are the generally presented in the river. And you can see on the figure on the left side, you can see due to the sediment erosion, uh, around 30 to 40% of runner blade is damaged and eroded. So, every time the maintenance takes a lot of time and a lot of effort to firstly to remodel it and try to manufacture it. So we are using this reverse engineering method to make this process efficient and quick. And another cause of the erosion is cavitation erosion. Cavitation is rapid formation and collapse of vapor bubbles within a liquid when static pressure becomes smaller than a liquid vapor pressure. So there is no any problem just associated with the formation of the bubble. But when these bubbles travel from the low pressure region to the high pressure region, it and when it strikes to the surface of the runner or surface of the any other component of the turbine, it makes those surface eroded. And if we see on the right side of the slide, we can see a impeller that shows the how cavitation affected it in a long run. So the first image shows a brand new image of the impeller, and second shows the after 6 months what the cavitation has done to it, and after 12 months, and ultimately for 24 months. Like after 24 months, most of the runner blade are eroded. So this is the overall effect of the cavitation and sediment erosion. So this is the major problem associated with the hydropower established in a region like Nepal, where there is a large portion of sediment erosion in river. So moving on with the application of reverse engineering method for remodeling of such eroded runner. So firstly, reverse engineering method is a non-conventional type manufacturing process which involves deconstruction of existing component to extract design and construct it with additional information to enhance the performance of component. In this method what we do is firstly we do a 3D scanning of the model, then we try to redefine it in a CAD software, then we ultimately produce it. And we can see on the figure on the right side where the steps involved in reverse engineering method is explained. Firstly, it is a data acquisition process, that is by 3D scanning, and there is pre-processing, triangulation, feature extraction, segmentation, and surface fitting, and ultimately CAD model. And further, the obtained CAD model is goes through the validation purpose on a different CFD softwares. Then ultimately, after all those validation and safety check, then it is finally moved into the manufacturing process. So in order to understand the application of reverse engineering method in remodeling of a eroded Francis runner, we took a case study on eroded runner of Puakola hydropower station, that is in Ilham, Nepal, and the runner is capable of producing 3.1 megawatt of hydropower. And we can see in the picture in the left side that due to the erosion, around 40% of the blade surface is eroded and damaged. And we firstly did a 3D scanning on the eroded model, then we try to redefine it and ultimately present the process that is involved in reverse engineering and how it is applicable in the whole remodeling of eroded Francis runner occurs. Firstly, to start with, we did a 3D scanning of runner, and this scanning was done in a jointly organized workshop by Turbine Testing Lab and Wuhan University on 3D scanning of Francis runner by reverse engineering method on 20 to 24th November 2019. And for this scanning, we used a scanner Creoform, EXScan, and software VXELEM. So the process that are involved in the 3D scanning of the runner, the first process involves the target surface preparation. In this step, what we do is we try to identify all the surfaces of the runner. Then we calibrate the scanner using calibration plate. We calibrate the scanner so that it takes a proper reading. Then we position a target on the surface. What we do is we put the white white surface, white dot like structures in a triangular shape so that the scanner can detect it properly. And finally it is extracted into the CAD model, then we save it in the STL format. So this is the whole process that was involved in the workshop that was organized by Turbine Testing Lab and Wuhan University for 3D scanning of runner. So after 3D scanning of the runner, we were able to extract a CAD model of the eroded Francis runner. And in this section, I will address you the reverse engineering design methodology for remodeling of the eroded Francis runner. And the pictures on the right side represents that the first step is part digitization, then is surface approximation, creation of the CAD model. So all these first three steps are the 3D scanning process that are involved. And after we are able to extract a CAD model, then what we do is we do a meridial profile specification, then we define a blade angle, then a blade thickness, then we analyze, then we try to validate it in a CFD software, then we finally manufacture. So these are the basic reverse engineering design methodology that is involved in remodeling of a eroded Francis runner. So for our design methodology to remodel eroded Francis runner, we took a reference of an Indian standard book of similarity check between model and a prototype. And the figure on the left side involves the locations for checking outlet width and blade profile. Another one is location for measuring leading and trailing edges. So these are the reference that we took to extract a dimension of the scan model, and we tried to create a template over it, and ultimately created a 3D model out of it. And the figure on the right side shows the 3D scanned image of a runner. As you can see that it has a lot of missing part, maybe because of the erosion and due to complexity of the structures. We were only able to extract a very little. And another figure shows the meridional contour at section plane. So this is how we are going to create a template and try to ultimately create a you know uh, create a Francis uh, turbine runner. So this section of the slide represents the steps involved, how we did a reverse engineering on the eroded Francis runner using reverse engineering tool. And for this we used SpaceClaim, ANSYS SpaceClaim software, and we tried it with different software like SolidWorks, Scan to 3D, uh, SolidWorks Geomagic, and many other software. But we found that the ANSYS SpaceClaim is very useful in this approach, and we were able to extract it in lot quicker and efficient way in ANSYS SpaceClaim. So with this case study on reverse engineering method applications, we can conclude that reverse engineering method is very efficient in remodeling of a Francis runner. It makes a lot quicker and efficient of the whole process. But what we found is that the remodeling of a Francis runner and to obtain a mathematically correct model is very difficult because of the erosion and the complexity of the structure. We are not able to extract the complete dimension of the model, and the blade profile that is obtained is not complete, so the blade that is redefined is not mathematically correct. And what we find is that the additional optimization software should be approached and should be utilized so that the correct and mathematically sound model can be obtained with this reverse engineering method. So for our case study, we took a reference of all these articles that are available on the internet. They are found to be very useful for the whole process of investigation.
So thank you very much for the time and passion. If you have any queries or if you are interested in the project, you can write a mail to the mail address that is shown in the presentation slide. So thank you very much. Bye bye.